Friends, good morning, happy morning and a new morning. New morning with this new topic of atoms. One more time another easy scoring topic from our part 2 syllabus of second year. Now here comes Bohr atom. What do you mean by Bohr atom? An atom with a single electron is what is called as Bohr atom. Nothing to do with the number of protons inside the nucleus. Bohr atom is an atom with a single electron. Like if I take the case of hydrogen. Hydrogen has only one electron. It can be deuteron with one electron. Tritium with one electron. Right? Apart from them, we know that helium has two electrons. Helium plus. So hydrogen and its isotopes, when we consider, it becomes a Bohr atom. Now helium with one loss of electron, helium plus ion, helium single plus ion, not a double plus. Helium single plus ion is also Bohr atom. Similarly, now the case will go on. If I say lithium 2 plus, beryllium 3 plus, see all of them are Bohr atoms with the difference of atomic number Z. Remember, atomic number is not the number of electrons present outside the nucleus, rather it is the number of protons present inside the nucleus. Therefore now, when we are taking this Bohr atom, the most important point is also, our parameter is atomic number. This is Z is equal to 1, this is Z equal to 2, Z equal to 3, Z equal to 4. This substitution is important. So Bohr atom is a single electron atom. Now entire analysis of our atom depends on three postulates. Among that, first two postulates we shall make use to find all the characteristics of the orbital electron inside the atom. And the third postulate we shall use it for understanding the hydrogen spectrum or spectrum of any Bohr atom. To find or to study, we make use of the third postulate. Now, I don't want to write those postulates, but just I want to give you as a statement. First postulate says that all the electrons revolves around nucleus in different circular orbits and they are called as stationary orbits. Remember, this is what is the difference between Rutherford model and Bohr model. Bohr says they are stationary energy levels, they are stationary orbits. Second postulate says that the most important thing, in fact it is the revolution that has changed the world approach towards the nature, and that is what is the quantization principle. Now according to Bohr, angular momentum of orbital electron in Bohr atom is quantized. Remember, quantization is different from conservation. Conservation means something, some entity as a whole remaining constant, whereas this quantization means something existing in discontinuous or discrete special values, then called as quantization. So quantization of angular momentum is second postulate. L is equal to mvr equal to nh by 2 pi. That n is what is principal quantum number, which represents the number of the orbit. In the Bohr's first postulate we said number of circular orbits. Each of the orbits given number 1, starting from the one which is closer to the nucleus 1, then number 2, 3, 4, so on. That number is what is referred as principal quantum number. And what is Bohr's second postulate? Now, two postulates, two equations. First postulate says that circular orbit around nucleus for the orbital electron. Therefore, for circular motion it requires centripetal force provided by the attraction between the electron and the positive nucleus. Therefore, the first equation is 1 by 4 pi epsilon naught Ze square. If Z is the atomic number, Ze is the charge on the nucleus, E is the charge on electron. Ze square it becomes Q1, Q2. Coulombic force I am writing. Ze square by R square, where R is the radius of that particular orbit in which electron is revolving. is providing the necessary centripetal force. Coulombic force providing necessary centripetal force. Now this is the first postulate, and second postulate is quantization of angular momentum, which we will write it as MVR is NH by 2 pi. NH by 2 pi. Else this one also I will just write the other way around. Centripetal force provided by this Coulombic force. Now these are the two equations which we need to solve. And again I am telling you, why I am telling you these postulates, because maybe sometimes if we forget the expression that actually we have practiced, then these things will help you. Because now in these two, if you supposing if you eliminate V, then you get expression for R. If R is removed or eliminated, we get expression for V. So that is what is our job. Now I am going to give you those expressions and important discussion how to look at those expressions. But in case you actually it happens to forget, then you have these two equations and you can actually derive. Now let us see those expressions for radius of the orbit and velocity of the orbit. I am now writing. See, equation 1 and 2 we have, where solving these two, now I am getting the expression for radius of nth orbit. This is not r into n baba, this is r1, r2, like first radius of the first orbit, second orbit, that meaning it comes. Okay, let me not write that also. Or radius of nth orbit is h squared epsilon naught times pi m e squared times n squared by z. So this is what is the expression we get for radius. Remember, today's expression I will give you only three and only three expressions. Using those three, we can do many others, and at least in 20 seconds we can derive any other expression, right? And even I am telling you, not necessarily you remember this expression, and don't try also, because definitely it is not possible. But afterwards for our CET NEET, whatever useful form we require, we will write that. But for my specific or special discussion, I am just writing the complete expression. Now here, what is that we find? This radius, see, h square, Planck's constant, epsilon naught permittivity, pi a constant. All the other things you look at. Now radius depending upon m, which is mass of the electron, and it is inversely related. And also you see, it depending upon the charge of the electron, again you will have the inverse square relation. Because generally student will be looking at only one point, because generally discussion goes on, radius depends upon the principal quantum number, r proportional to n square, and also it depends upon atomic number. Yes, most of the examples are based on them only. But still we can also look at these important parameters in the brackets. Because sometimes if it is said that an hypothetical atom where those particles are not electrons but particles whose mass compared with electron, whose charge compared with electron, for such cases what happens to the radius? So such hypothetical questions can also be asked in physics, and that is why remember, this is radius depending upon mass of the electron, charge of the electron, both are inverse. And also now comes to this point n squared and z. Therefore our result is r proportional to n squared by z. So whenever it comes to the radius, r proportional to n squared by z, what does it mean? It means r1 by r2 is n1 by n2 squared, and this is z2 by z1. Comparisons, or one radius given, asked for the other radius, like that. When do we come this z1 by z2? Given the value of some radius for one particular Bohr atom and asked for other Bohr atom. In such case, we have these z values. As earlier I have told you, we have all the cases of hydrogen, helium plus, lithium 2 plus, like all those things are there. Supposing for the same atom, if we are comparing, this z2 by z1 will be equal to 1. So in general, I am giving you this Z2 by Z1 or Z1 by Z2 in all those expressions. But in this case of same atom, that ratio happens to be 1. So this is what is the expression for radius. Expression for radius. Now similarly, as I have told you, from these two expressions, if I eliminate this radius term, then we get the expression for velocity as V, velocity of orbital electron in nth orbit is E squared by 2 epsilon naught h, this is all constant term, times Z by n. Remember, this is radius of nth orbit. First orbit, substitute n equal to 1, second orbit likewise. Similarly, this also velocity of orbital electron in a definite orbit. One more time, look at this expression with more and more details. Earlier we said radius depending upon mass of the electron and charge of the electron, both being inversely proportional, and then n squared by z. Now what about the velocity of orbital electron? Look at this constant term in the brackets. Where you find that this depends upon charge of the electron but not mass of the electron. Velocity of orbital electron in the Bohr atom independent of mass of the electron, depends only on charge of the electron, and that one is also, you will find that V proportional to E square. So these are very important observations that we can make, and of course after that we have V is equal to E squared, and this V proportional to, we have Z by N. V proportional to Z by N. Look here, V and N inversely proportional. Higher and higher orbits from the nucleus, velocity gradually decreases. Earlier we have seen radius inversely proportional to Z. Here V proportional to Z. Now what I need to tell you is that we have to remember these proportionalities. Most of the examples afterwards comparison of different characteristics of orbital electron, these two are our basis. After that, this combination will give you many other things. So for all of them, the building block or the step is the proportionalities that we have taken for R and V. Right? Look at these expressions. And now, after this, I would like to give one more thing. Supposing if it is our NEET or CET examination, sometimes ask you to calculate the magnitudes directly. May not be a question, but maybe somewhere on least probable case. In such case, actually we will find substitution of all these numbers, really it's a time taking one. For such case, now I just would like to give one more simple expression to remember. What is that expression is this radius R is equal to, if you substitute all those values, you will get it as 0.53 times n squared by z. Particular value of n we will substitute and z we will substitute, and answer is directly in angstroms. Suppose if n is equal to 1, somebody said, then what happens is 0.53 angstroms. 0.53 into 10 raised minus 10 meter. Is it right? Or minus 8 centimeter becomes the answer. So this is 0.53 angstroms for n equal to 1. Similarly, for given value of n, for given value of z, we can easily calculate the values of r. At the same time, even for velocity also, this we have done in the classroom, you remember. So just I am reminding you, because if it is more and more list of formulae, it will be a kind of stress element, and that is why I am trying to minimize the things. Now here, this velocity v is c upon 137, c for speed of light, c by 137 times, yes, of course we have earlier said z by n. This will be in meter per second. Always when we are expressing any magnitudes values, options A, B, C, D, the units are very, very important. The C value 3 into 10 raised 8 meter per second. So that value by 137 times Z by N. In fact, if you do that number, the C by 137 value, quite interesting concept. You see, I can create one conceptual question. How? Based on this one, I'm telling you. This one is say 3 into 10 raised 8 by 137. If you take this number, it will something be like yeah, 2.2 into 10 raised 6 meter per second. Yes. For n is equal to 1, z is equal to 1. I have calculated this value v is equal to c by 137. Therefore, you see here, this is what is the maximum velocity of orbital electron in hydrogen atom, not the Bohr atom, hydrogen atom. Because if it is helium plus or lithium 2 plus, this value of Z multiplication factor will come. I am talking particularly about hydrogen atom. Hydrogen atom, the fastest electron in the hydrogen atom can have, see, this is what is the value. There cannot be velocities greater than 2.2 into 10 raised 6 meter per second. Now, if you compare this with the speed of light, what is the percentage? Again, it can be a question, is it not? Then it becomes 2.2 by 3. That nearly comes around 70%. 0.7, and then 10 raised minus 2 is also there. Is it not? 10 raised minus 2 is also there into 100. So this is what is 0.7%. 0.7% of speed of light nearly is the fastest velocity or that of orbital electron in the Bohr hydrogen atom. So now I have given you expressions for radius and velocities. This is sufficient for our next discussions. So, since we know radius and velocity, afterwards we can write all other characteristics such as circular motion is there, so we can write angular momentums, we can write kinetic energies, we can write potential energies, and afterwards all the other characteristics of electron I will now discuss. Let us see these parameters of energy aspects. When it comes to energy, to begin with, the kinetic energy by virtue of the motion. Afterwards, potential energy. Why potential energy for orbital electron? It is not that mgh gravitational potential energy, but it is electrostatic potential energy. Electron, a negatively charged particle in the field produced by the positively charged nucleus. So that concept of electrostatic potential energy and hence the total energy. Now, to begin with, again I am telling you, we may sometimes may not recollect the exact expression as it is immediately after reading the question, and that is why this will help us. Earlier we have told this mv squared by r, that is the centripetal force for the orbital motion provided by this 1 by 4 pi epsilon naught z squared by r squared, the coulombic force. Then if I just those cancellation, yes, R will remain. This is mv squared now. Suppose now if I do mv squared by 2, this 4 becomes 8. Is it not? So that is how I have shown. mv squared by R provided by coulombic force. Then small changes will show you mv squared by 2. Therefore, this is what is kinetic energy. Kinetic energy, okay, kinetic energy is Jd squared by 8 pi epsilon naught R, and we know the expression of R, we can substitute that and don't try to memorize that also. But I think you can make out or you can remember this expression by your practice. So kinetic energy, we have got the expression, and remember kinetic energy is always positive. It can never be negative. Here when we are talking about orbital electron, the speed, the velocity, positive. Kinetic energy also always positive. So kinetic energy we got. Now if I substitute the value of R, then what is the expression that we get is an interesting thing. This is again me power 4 by 8 epsilon naught square h square times z square by n square. That is the result I get. See, an important expression, an important me power 4. Now kinetic energy depending upon, again, mass directly proportional, depending upon charge of the electron proportional to the fourth root of the charge of the electron, and then depending upon this atomic number Z, and that too Z square is there. And remember, we already seen that V proportional to Z by N, and therefore kinetic energy is V square term, therefore naturally it is Z square by N square. And that is how all the things become simpler if we apply our common sense. I have told you to remember only two expressions, that is R proportional to N square by Z and V proportional to Z by N. Afterwards what follows you can see most of it is common sense. Not at all a memory, again and again I am telling you. So now I have this kinetic energy and therefore now I write the potential energy. While writing potential energy, many a times in the classrooms we have used one principle, one concept of bounded system. See, atom is a bounded system because the nucleus, electron bound with an attractive, Coulombic attractive force, it's a bounded system. For any bounded system, what is the property? Since it is one more time that we are talking about, let me repeat three important statements. For a bounded system, kinetic energy is always positive, of course, not a big statement. Potential energy is negative. For any bounded system, potential energy is negative. This is what is the criteria for a bounded system, such that potential energy is double the kinetic energy in magnitude. So here negative term is there for potential energy and double the kinetic energy in terms of its magnitude. Therefore now when we consider the total energy, kinetic energy plus potential energy, K kinetic energy, double the kinetic energy with negative sign, minus 2K will be potential energy, add will get minus K. So potential energy negative and double that of the kinetic energy. Total energy is equal to negative of kinetic energy. So these are the principles which straight away will give us all the results. One has to remember only one expression, that is the kinetic energy. Potential energy expression. Potential energy expression is double with negative sign. Double. 8 is there, it becomes 4. Therefore minus ZE squared by 4 pi epsilon naught times R. Here also the only difference is that same me power 4. Here it becomes 4 epsilon naught square S square Z square by N square, of course with the negative sign, minus of me power 4 epsilon naught square H square times Z square by N square with negative sign. So this total energy will be negative of kinetic energy. So for orbital electron the total energy is negative, which is the significance of bounded system. Now what is the total energy that we get? Total energy is minus ZE squared by 8 epsilon naught, pi is also there, right? 8 pi epsilon naught R. Now this same expression by substituting the value of N, this is what is energy. Energy of orbital electron in nth orbit E is equal to, as I have to do, negative of kinetic energy minus me power 4 by 8 epsilon naught square H square times, of course you have this Z square by N square. Do remember, along with the negative sign we have to use. So all those stationary orbits in the hydrogen atom have negative energy. Why? It can be a question for assertion reasons or true and false, because the potential energy is negative and it is double that of kinetic energy. Total energy always negative. In fact, the same expression to discuss our hydrogen spectrum we have just converted into another useful form. What is that useful form? You know that? This is minus me power 4 by 8 epsilon naught square CH cube. So in the denominator I am multiplying CH. C for speed of light, H for Planck's constant. Then here I get C times H. Then you have the same usual Z square by N square. Now this me power 4 8 epsilon naught square CH cube, this is the one which is called as a universal, again one more universal constant called Rydberg constant. I am writing it as capital R value. The number is very important. I would not like to give you the number. Please go through your class notebook and write that value for R. Number, when you are writing, at least 2 decimals, and the order with unit is very important. Rydberg constant has a unit of, yes, meter inverse. Per meter is the SI unit. Meter inverse is some very special appearances in our physics. Where do we have other meter inverse units? Try to recollect yourself. Focal power in optics, you remember? Focal power in optics has the unit of diopter, which is meter inverse again. Similarly, you remember wave motion. Wave motion we have a constant called propagation constant of the wave. Propagation constant again 2 pi by lambda with meter inverse. So Rydberg constant, propagation constant, this focal power, all have the units same, which is meter inverse. So this is what is again one more expression, R C H times Z square by N square is the expression for energy of orbital electron in nth orbit. So here, what is our take? What is that we need to understand? Again, one more time. Since we know what about the characteristic radius, whether it depends upon the mass, charges, and how, whether inverse relation or directly proportional. Again, velocity. Therefore comes kinetic energy depending upon mass, charge, but look at the index, and also depending upon this Z square by N square term. So these are the important things that we'll take, and not last but not least this value of R. Because the value of R is so important that in the examples based on the Heisenberg spectrum may not be given the value of R as a data, you need to remember and substitute. Now let us see some other characteristics of this orbital electron based on these 2 or 3 characters that now we have discussed. Let us see that. In the discussion of the other characteristics of orbital electron, now let us see the beauty or uniqueness of our subject physics towards these competitive examinations. Because when it comes to these examinations, people think that many list of formulae and too much of memory, which is absolutely wrong approach. In fact, number of times we are told it is less memory, more logic is our funda for physics. Now, physics is a bit continuity, in fact all the fundamentals in particular topics, and it will be an ever continuity. Now today in the present session, for about 5 to 10 minutes, I am not going to give you it as a list of formulae, but you will see them as how that common sense used in connecting those parameters. Right? What are those parameters that I am now discussing? Yes, circular motion is there, therefore it is number of revolutions per second, the frequency, reciprocal, what is time period, then it is orbital motion of electron, therefore what will be its angular momentum. After angular momentum, what is the concept of this electron revolving produces orbital current. That current makes it as a dipole. That dipole moment, how much, and what is the magnetic induction produced by them. I can go on listing all such things, and these things which we have already discussed in our electromagnetics. Even the case you see, since it is an orbital electron in motion, it is associated with the de Broglie wave, whatnot, everything like this. Now let me show 1 or 2 things how we are going to get. To begin with, as I have told you, we will simply remember 2 expressions. What is that? R proportional to, yes, n squared by z, and velocity proportional to z by n. So these are the only 2 things that we have to remember actually. Afterwards everything is a derivative from this only. Therefore now if I take the frequency of revolution, frequency proportional to, we know that omega is equal to 2 pi f, omega is v by r. Therefore f proportional to v by r. F proportional to v by r will tell you that it is f proportional to z squared by n cube, is it not? F proportional to z squared by n cube. Now actually we should not try to memorize this, rather it can be observed from these 2, right? frequency proportional to 1 by n cube in a particular Bohr atom. Suppose if Bohr atom is also changing, then it also depending upon this value of z. If we take the reciprocal, yes, we have the time period expressions capital T proportional to n cube. Already we have one relation. What is that? R proportional to n square. Now supposing if it is a relation between radius versus time period, the radius versus time period using this expression, what is that you get? Again you will get T squared proportional to R cube. Very interesting thing, which is the thing back Kepler's planetary motion, one of the law. T squared proportional to R cube applicable for planet revolving around Earth. The same applicable for even the microscopic world, the atomic world, T square proportional to R cube for the orbital motion of electron. Now supposing if we take a orbital current we have defined in our current electricity topic, you remember, as I is charge times frequency. Here the charge is electronic charge times frequency. Therefore once again I proportional to F. I proportional to F, and already we know about F, therefore I proportional to Z squared by n cube. Orbital current of electron in Bohr atom, first orbit, what will be the for the second orbit or third orbital, what is the changes? See, they really appear to be very tough, and all these formulae can never be memorized. The concept can only help us in the examination hall. That moment, that challenging moment, really our practice for all these students. Again we have lots and lots of time. Keep on requesting you to make the best use of your time, because post corona you getting admission in one of the premier institutions in Karnataka or premier institutions in India really makes you so happy and special in the coming decades. Do remember that. So this is what is fourth orbital current. Supposing somebody, the recent one or two sessions we talked about de Broglie wavelength. Supposing if I have to talk about de Broglie wavelength, this de Broglie wavelength we said lambda proportional to 1 by P. There P for momentum therefore it is mv. Lambda proportional to 1 by V. Therefore lambda proportional to 1 by V. Already we have told V proportional to Z by N. Therefore lambda proportional to N by Z. One more simple result. So first orbit, second orbit is directly proportional. First to second, double, right? Second to third, not double. Second to third, 3 by 2 ratio get. Therefore it is increasing 50% so on. So lambda proportional to N by Z, lambda 1 by lambda 2 comparisons. Is it not? Supposing if we now write angular momentum. Very special thing, because I would like to talk about angular momentum in the last part because of its specialty. Now let me take its magnetic moment of orbital electron, an important concept where we get already discussed about Bohr magneton also. Remember the shortest dipole moment in the nature due to the orbital motion of electron in Bohr atom we have discussed. Please go through that. An important point, that number is also universal constant. Remember the number and also the expression. Now the magnetic moment M, we have given an expression like the current times area, which is pi r square, and now we know that I proportional to Z square by n cube, because we don't remember that but we remember the frequency. Therefore M proportional to F times R square, and we know that this F is proportional to Z square by n cube. Here you have R square term, right? R proportional to n square by Z. Therefore this is n raised 4 by Z square. Yes, this is what you find, capital M proportional to n. Capital M proportional to n. So far all those expressions we have seen depending upon both the value of n and Z. So whatever may be the value in hydrogen atom may not have, does not possess the same value in the helium plus atom or lithium 2 plus. Same first orbit if we consider in hydrogen, helium plus, lithium plus, these characteristics will be changing because you will see dependence on Z. Whereas magnetic moment of orbital electron is independent of the Z. Supposing hydrogen atom, first orbit, orbital electron producing a magnetic moment M. Afterwards it is He plus or lithium 2 plus or beryllium 3 plus. First orbit, the moment will be the same. Therefore remember, it can be a question, which of the following parameters is independent of atomic number? Then we have only two examples for that. One is magnetic moment. Of course the other one is angular momentum. Because what is the quantization principle, you tell me? Angular momentum is nh by 2 pi. That n for principal quantum number, no question of z there. Therefore, in the entire Bohr atom, the characteristics which are independent of z and depends only on n are number 1, the magnetic moment, and number 2, angular momentum. No z term here, please do remember. No z term. Magnetic moment. Similarly, what is the magnetic induction produced by the orbital current? Again, really no one can remember such. But what one principle we have told? We have told it as a concept in our electromagnetic discussion, that due to orbital charge B is equal to QV by 4 pi r square was our result. QV by 4 pi r square. Yes. And here Q, I will write it as small e, charge of electron. Charge of electron. Therefore, now here what we observe is that B proportional to V by R square. Once again you have the substitution and numbers. So this V nothing but Z by N times R square means, yes, N by 4 by Z square, giving you finally Z cube by N rise 5. See, B proportional to Z cube by N rise 5. Likewise, all the characteristics of the orbital electron we can evaluate or we can compare by using only two expressions. So this is what I wanted to show you, your approach. So you practice that, what is the concept in electromagnetics, what was the concept in circular motion, what was the concept in de Broglie wavelet. The same things you will have in the examination also. There you can find your expression at least within 10-20 seconds. You will get your answers. Specifically, let me come to energy topic. This energy and numbers are very important when we read the question. Again, we have given the expression for energy in terms of Rydberg constant also, substituting all those values. For our NEET CT examples, let us remember this expression. Energy of nth orbit is minus 13.6 z square by n square, and it is in the units of electron volt. So all that substitution will give us. Of course, as I have told you, the total energy of orbital electron always negative. And this is z square by n square. Again I am telling you, for any Bohr atom we can use the same expression. And one more thing, the unit, it is electron volt, not kilo electron volt or not MeV, not joules. So it's an important thing about the unit. Now here, the numbers as I have told you, suppose what is that E1? First energy becomes minus 13.6 eV. Now for what is that E2? E2, n is equal to 2 means 4 minus 13.6 by 4 it will be, right? It will be 4. Then 4 threes are 12, and then this one is minus 3.4 electron volt. You see the negative value is decreasing, that is where we say the energy of the orbital electron is increasing with the principal quantum number. Now similarly you will go on numbers like E3, it will be by 9 ones are 9, 4 and 6, therefore it will be 9.51 electron volt and so on. And looking to these numbers, remember the energy difference between first and second is huge as compared to second and third. That is, that energy difference is gradually decreasing in the case of a Bohr atom. Generally, this is a very famous figure representation we observe in our notebooks or textbooks. What is that? Suppose if this is what is n is equal to 1, now this is where this is n equal to 2. This is where n is equal to 2, and this is n is equal to 3, then this is what is n equal to 4, so on. Remember, in this representation, it is not the physical distance between the orbits. Physical distance between the orbits is a different picture. This is completely energy level diagram. The energy difference between the orbits gradually decreases. Whereas, when it comes to the question of physical distance, the orbits, the correct representation would be like this. See, if this is what is the first orbit, if this is what is the first orbit I am taking, then first orbit to second orbit are proportional to n square, 4 times it becomes. Therefore, this will be what is, this is n is equal to 1, this is n equal to 2. Now n equal to 3, it is 9 times, therefore we will get radius like this. This is what is n is equal to 3. So here what we observe? The physical distance between first orbit and second orbit, and the physical distance between second and third orbit. Compare, this difference is huge. So as the principal quantum number increases, the physical spacing between the orbits very much increases. Very much increases. That spacing you see here, this is r, this is 4r. Therefore, this distance will be 3r if small r is the radius of the first orbit. Then what about this distance? This distance will be third. Third means 9 times because 3 squared. Then second means 2 squared 4. 9 minus 4. This is what is 5r. Next comes 7r. Therefore, radius are in the ratio. You see r1, r2, r3, so on is in the ratio 1 is to 4 is to 9 is to so on. Whereas the spacing, if you take the spacing ratio, if I ask it in the examination, r2 minus r1, yes, is to r3 minus r2 is to r4 minus r3 and so on and so on. The spacing between successive orbits, when you consider, now you are getting those odd multiples, that is 3 is to 5 is to 7 is to 9 is to so on. So here this is only energy level diagram, not a physical spacing. These numbers are important. Now you can as well write the kinetic energies. What is the kinetic energy in the first orbit? You remove that negative sign, that will be kinetic energy. With the negative energy you are getting total energy. If you drop that negative sign, it will be kinetic energy. Then keeping that negative sign and multiplying it to double the number will give you potential energy. Because earlier we have told total energy is negative of kinetic energy and potential energy is double the kinetic energy of negative sign. Use that. All numbers, now it will be easier. Minus 13.6 total energy, plus 13.6 electron volts kinetic energy, minus 27.2 double with negative sign becomes potential energy, and same is the case with other orbits as well. So this is how energy expression we will use. Even supposing if this is our understanding, then time management is easier. Otherwise, all the examples in the case of atoms and nucleus, though they are very easy, the toughness is with respect to the numbers and the calculation. There I want you to be smart by just using your common sense, right? So this is about the Bohr atom and first two postulates. In our next session, we will continue with the third postulate of hydrogen atom and how to understand the hydrogen spectrum. Thank you. Have a very good day.